Okay, in this lecture, we're going to talk about best practices. So it's not so much a lecture as I just want to cover this page. I'm not going to go through everything. I just want to highlight some things, and then I want you to come back and read it. So I'm not actually going to lecture in the traditional sense and like teach you best practices. This is much simpler than that. This is just a list of things that you need to do to produce good code. Okay. And most of it, I'm going to rely on you to read. I'm just going to highlight some pieces to kind of get you on the right track, and then you do the reading and you do the work to figure this stuff out. Because none of it's complicated. It's more like just a set of rules, right? It's just like do this, do this, do this, do this. It's not like you got to think about it a lot, okay? But I want to explain a few things, just make sure you're on the right track with this stuff. Okay, so what do we mean by best practices? So we have guidelines in the world, and everybody has that. Every profession has that. Okay, we have things you're supposed to do as part of every profession. That is the professional way of behaving, the professional way of getting work done, the professional procedures in that industry. Okay, and programming is no different. In fact, it's probably one of the stricter ones. Okay, and it's one of the ones with probably the biggest set of best practices, right? So these are things you have to follow in industry to be a good programmer, okay, and to be a good software engineer, be a good architect, be a good technologist. Now, in this case, though, this is going to be a combination of industry best practices and academic best practices. Okay, so there's a combination there, and some of them are not necessarily things you have to do in the professional world, but there are things that you have to do as a student to learn discipline or to learn focus. So this is a very big list, and it's a combination. Okay, probably most of it, I'd say probably 60, 70% of it is going to be industry standard. These are things that you do in industry. You have to do it. If you want to be employed in this field, this is what you have to do. Okay. But then we have like a substantial set of things that are just academic or for teaching purposes, which means in the real world, would you really do all of these things? Maybe, maybe not. You'd probably lean into them. They're not there for no reason, but they're bendable or even sometimes breakable because they were there to teach you something that once you become good at this, you'll know when to use it, when not to use it. Okay, so we have a mix of these things, all right? And I'll try and point out some that are in each category. Okay, so these are general guidelines to proper coding practice. The goal is to teach you to write clean, elegant, efficient code that's easy to read and understand. Now, as I said, not all of these standards translate directly to industry standards, but they're all good practices to help train you, and many of them, most of them, do translate to industry standards. Okay, so let's go through these. Now, you have to know, like, it says up here, it says where it says, again, it says general guidelines, right? But let's be more specific for coursework. It applies to all programming courses unless otherwise noted, and you have to follow these. Okay, these aren't suggestions; they are rules. Okay, so from your perspective as a student, these are rules. You have to do them if you want a good grade. There's no not doing these. Okay, there's no choices here. Okay, these are all like you have to. Okay. You must do formatting, spacing, and bracketing correctly. Okay, and then there's a formatting guideline. I'm gonna let you read that. I don't need to go through that. Python like forces formatting on you as part of the language, so you can't screw that up. But in C, you can screw all sorts of things up. So we have formatting guidelines for that. So you click that link, you follow, you go there, and you read about it. Naming conventions. We name things a certain way. Again, I'm not going to cover all of these. Like, read this and read it carefully because you are going to be graded on it. I guarantee you'll be graded on it. Let's just take one example. You may not use cryptic names. You can't call variables X or A1 or A2. You have to give it real names. Your code has to be self-documenting. It should read like English. Okay, so you need descriptive names. If you use cryptic names, meaning something that you can't figure out from just looking at it, you're going to get a bad grade. Okay. We have different ways of writing names. You can read about that. We have underscore convention, camel case convention. We use capitals and lowercase in a very specific way in programming. Okay. The default rule is everything's lowercase, and then we have exceptions for when you use uppercase. Okay. Like constants are all uppercase. Okay. Class names and other abstract data type names, they have an uppercase first letter and then lowercase or camel case for the rest of it. Okay, so you read through those, make sure you understand them very well. Okay, namespaces. This applies mostly to C and C++, but we never use using namespace standard. That's a professional standard right there. If you write using namespace standard professional code, you're probably not going to be employed long. Okay. So, or at least you're not going to be respected. So we don't use that. There's a real reason for it. I'm going to cover that in class and talk about, we talk about theory and all this kind of stuff, right? And this explains that. So you read this and make sure you follow those rules. Okay. In Python, we don't. It's different, right? We do have namespaces in Python, but they're managed a little bit differently. They're imports, and when you do something like this, import math, you are pulling in a namespace, okay? But you don't really always want to pull in the whole namespace. It's probably better to isolate things in the namespace. But again, I'm going to cover this more in class. But once it's covered in class, like you're going to be expected to follow these rules. We don't use literals. You should know that. Read this to explain why we don't and what the exceptions might be. And remember, there's always exceptions for everything, right? So one of the things in programming is programming is to me it's really interesting because this is how we talk in programming. We always do this. We always say always do this or never do that. Like we always say things like that, right? And I just said we always say things like always, right? But then we immediately follow that with except, and then we list the exceptions. All right, and that's a very programmer mindset, right? Because in programming, that's really how you program too, right? When you write programs, when you write code, like code is definitive. It is science. It is math. It is like I am doing logic, okay, and that's the way it is. But we literally have these things called exceptions, okay, like the actual formal word exception, right? We do exception. We actually have a thing. We have a whole topic called exception handling. Okay, so even in programming, we write the way we speak and we speak the way we write. So like when we talk about programming rules, it's very common to hear a programmer go, "Always do this." Okay, never do that. But then they immediately follow that with except in this case or that case, right? And you can see that here. Okay. So it says here, all variable names must be named with descriptive names. So like this could be a rule like never use cryptic names. Okay, but then the very next thing we do is we go except, right, counter variables, right? With counter variables, we use IJK. Okay, we don't make them any bigger than that. Okay, because we know what IJK is, so we have an exception to that rule, and we have other exceptions. For example, X, Y, and Z are usually generic floats. Okay, and there's a few other examples too. But just realize that that's kind of the way we talk in programming and software engineering. We use absolutes because that's the way programming is, and then we use exceptions because that's the way programming is, right? Same thing down here. It says now in this case, this one's pretty strict. Okay, that one's a real never. There's no except. This is just a never. Okay, and then down here with literals too, same thing. We say we have a rule. Don't use literals in your code. That could translate to never use literals. And then we have exceptions, right? We go except some literals are okay, like -1, 0, and 1, because they're used in such a way that can never be changed. Okay, they're immutable. All right. So because like for example, all arrays start at 0. That's built into the language, built into the architecture of the machine. That can't ever be changed. So if you want to use 0 to indicate the beginning of a memory structure, it's always okay because it can never be changed. So you can always use it, and then we use literals. Okay, so there's a rule here. It goes never use literals except. Okay, for those cases. Okay, Boolean expressions. You should, if you don't know what that is yet because you're in programming one, it's okay. Don't worry about it. I'm not going to cover it too deeply. Just be aware of this idea and then come back here and read about it again when you know more about it. So Boolean expressions should never be more than 3 or 4 expressions long. The reason for that is if it's bigger than that, you're probably doing too much. And I'm going to bring that all together here in a little bit when I talk about functions. Same thing with branching. You should never nest more than 2 or 3 statements long. If you are, it's probably you're doing too much, right? Programming is about small bite-sized pieces, and that's what these rules are about. Okay, these rules are about minimizing the complexity. We don't make giant complex things in programming. We make a collection of simple things that together build a complex thing. And whenever you see a programmer writing very complex things in a small amount of space, we call that clever code. Okay, and that's not a compliment. Clever code is an insult. When somebody accuses you of being clever in programming or they accuse you of clever code, what they're really saying is you're making it purposely difficult just because you're showing off, want to show everybody how smart you are, but all you're doing is making it worse for everybody else. Okay, because we all understand it and we don't like it. Okay, so we keep things simple and we have rules that say no more than 3 or 4 Boolean expressions long, no more than 2 to 3 if statements long. Now, again, there are exceptions to that. There are times where that comes up. where you need more than that, and it's acceptable. But as a beginner, you want to restrict yourself because then, as you know, as you grow and as you become an intermediate and an expert, you'll know when to break that rule. But as a beginner, you just don't because you don't need to. You're not doing anything hard enough to break that rule, right? Repetition. This one gets more complicated. Again, it starts with no more than 2 or 3 loops nested at a time. 4+ loops is usually an indication that your current module is too complex. Now we're talking about nesting here. So this is nesting, this is nesting, this is compound, which is, you could say it's kind of like nesting, all right? We're not saying you can't have more than 4 loops in a function. We're saying you can't nest them more than that deep, okay? But we have lots more rules with looping. So I'm just gonna hit some of the highlights, but you wanna pay extra attention to this one. So I'm gonna stress this, extra attention to this section, okay? Because all of the things in this section, I guarantee, are things that you're doing wrong. Okay, that you're doing right now. If you're brand new beginner programming one, you haven't programmed before, you're not doing anything wrong. You actually haven't done it yet. But I want to stop you before you do. If you are in a second or third or fourth class, you are probably doing these things, and you need to stop. Okay, because these are professional standards. Okay, most of them. Okay. We don't ever write purposeful infinite loops like while true or while one. Okay, that is sloppy amateur code. You don't do that. Okay, we don't call function and loop headers. For example, you don't write loops like this where you call like get count inside the loop header. Instead, you call it outside, and then you use the variable inside. Okay, and there's reasons for that. I want you to read them. So I'm not going to go through all the reasons. This is not a theory discussion. I want you to read them. It explains it right here. Okay, and why you shouldn't do that. And these are professional standards, both of these. Everything so far I'm saying is professional standards. Okay, now here's one that I consider a professional standard. Other people don't. I've had lots of arguments about this. I actually wrote a paper on it, well, like a journal paper on it. I did experiments on it, and I think I'm right. Other people argue with me. Most people agree with me. Some people don't. Do not use break or continue. So this is one of those ones that it's an arguable professional standard. There are definitively professionals who are very good at this job who would say using these are fine. Okay, I had a really huge argument with a PhD professor at another university about this one, right, where they were in favor of it, and like their code was awful, and I couldn't like help myself but just tell them how awful their code is, and that's what this comes down to. When you use break and continue, it generally means you're going to be writing sloppy code. There's almost always a better way to do it, okay? Using break and continue usually indicates your logic is faulty, all right? There's almost always a better way to do it. This is one of the worst things that people do in code, not because it's inherently bad. It's not that it's so bad in the code itself. It's that the mindset of the person who needs it is usually a bad programmer. Okay, or an amateur. Let's not say bad programmer. They might be beginner. You might need it because you don't know other techniques yet. But anyone who's good at this, anyone who's truly an expert at this and really understands logic and critical thinking and computational thinking, you can avoid break and continue 99% of the time, and your code is better. Okay, so my argument for this is very simple. Most of the time, by most I mean well over 90%, you can write better code without it. It's as simple as that. You can write better code without it, okay? And if you show me a case where you think you need it, I can probably show you a case where you didn't and the code is better, all right? So in the professional world, this is not a standard. In the professional world, you lean away from it. You don't necessarily ban it, but you say, I don't use it unless I have to. And then the best programmers, they don't have to, okay? Now, academically, I'm saying you can't use it. Okay, I'm forbidding it completely and totally. It's forbidden because that's a teaching technique. I want you to think about your code differently. I want you to have a higher standard, and I want you to think of more intricate, more interesting, and more elegant ways to form your code than break and continue. The way I look at break and continue is they're like sledgehammers. Okay, it's like you stick a condition inside of a loop. It should be running clean. It should be running elegant, and you jam a condition in there that says like when some condition becomes true, just blow up the loop and jump out of it. Okay, you should learn to code better than that. Okay, and I have some examples of that below. All right. So in compiled languages, we don't declare variables inside of loop bodies, but we do declare loop control variables in the loop header. Okay, so you read about that. Okay, now if you don't understand that, make sure you go back and read it and understand it. Don't place if statements inside of a loop if you can help it. again, this is just a guideline. Okay, you need to really think about this one. Most people who put if statements inside of loops are doing it incorrectly and are doing it in such a way they didn't need to. Okay, especially beginners, especially people who are just starting out, especially students. Most of the time, you shouldn't have an if statement inside of a loop. There are very specific cases where you need one inside of a loop, and typically if you're searching for something. If you're searching for something, you typically need an if statement inside of a loop, especially if it's a counting loop. All right, but other than that, you really don't. And people use them all the time, and it's really sloppy code. It's bad code. It's code that doesn't optimize well. You should avoid it. So every time you put an if statement inside of a loop, you should stop and ask yourself, do I need this in here, or am I just being lazy? Okay. Now, these two are the most important ones, and I'm kind of hanging on this part because the loop stuff is the most intricate of these standards. Use determinate loops when you know the number of things being counted. That means for loop. Use indeterminate loops, which means while loop, when you don't know the number of things being counted. Now, again, this is a professional standard, but in the professional world, it's kind of loose. Okay. In the professional world, if you break this rule, probably no one's going to bother you, but we can tell what level you are, right? A good, mature, expert professional, they're going to follow this perfectly. Okay. Intermediates, beginners, junior programmers, they're going to break this rule all the time. Okay, this is a matter of sophistication of your code and what level you want to take things to. You want to be excellent, then you follow these rules exactly. Okay, and there's real reasons for it. These are not made up, just stuff that I just thought of, just to make your life difficult. So now in the professional world, like I said, it's a guideline. You lean into it, but no one's going to fire you for not doing it. Okay, in class, this is a hard rule, absolutely a hard rule. If you switch these two, okay, I give you a bad grade and send it back and say you did it wrong. Okay, you cannot screw this up in class. Okay, and again, this is part of a teaching technique. I want you to think about it. I want you to know the difference between a determinate loop and an indeterminate loop, and I want you to know when one is used and when the other one is used. And I want you to understand there are real reasons we do that. It's not just made up just to make things difficult for you. There are compiler reasons, there are processing reasons, there are readability reasons, there are maintainability reasons. And those all go to professional standards, okay? And I explain that here. I'm going to let you read that, okay? So all of the stuff that's up here, I discuss it here, theory discussion. So it talks about all that, and then it gives you examples. And the examples are very clear. When you look at the examples, you will see, take this one, for example. This top piece of code, that's how a beginner would write code. So if I told a beginner, I want you to write me a loop where the user has to press anything. They can press a number, they can press something else. But if they enter 1, the loop will keep going. And if they enter anything else, the loop will stop. This is how a beginner writes it. The bottom one is how a professional writes it. Okay, and you can immediately see the difference. You can immediately see the bottom code is cleaner, neater, smaller, more elegant. It's easier to read. It's easier to maintain. Okay, it's a big difference. Okay, and just as a percentage, right? Like you got 1, 2, 3, 4 lines. 1, 2, 3 lines. Well, you're telling me that the top code is 33% bigger. And if you want to look at it that way. So now think about that in real life. If you're the kind of person who does this style, this top style, well, if you wrote a 10,000 line application, it wasn't 10,000 lines because you learned to code this way. It was really 13,000 lines or 14,000 lines, right? So that's that's bloat, okay? And now this is a small example, but now imagine if you keep thinking that way. If you learn to code in this top fashion and you never learn to do any better, all your code looks like this. All of your code is too big. All of it is harder to read. All of it is less elegant. All of it is bloated. And that just keeps getting worse and worse and worse as the code gets more and more complicated. So we want to get off on the right foot and we want to learn, don't use break, don't use endless loops. They always are a bad idea. They always make worse code. They're always inelegant. Okay, they're always harder to read. They're always harder to debug. Okay, so if you look at this bottom one, this is the way a professional would do it. And we have names for this stuff, right? So this top line here is called a priming read. Okay, what it says is it's a setup to begin a loop or to begin some process, any process, right? It's called a priming read. The reason that's given a name is because it's a proper professional technique. Okay. And then we have a proper condition. When I read this loop right here, if I read this loop header, I instantly know, oh, this will keep going until choice is equal to one. I know that from one line, and the line is exactly where I'm supposed to read that information. But up here, if I read while true, I don't know anything. All I know is the programmer for some reason wants this to go on forever. And then I have to read all the way to the bottom to go like, oh, wait, no, they don't want it to go on forever. They actually want it to stop at some point, but I didn't know that until I read all the code. Okay? Think about the difference between these two if the code was complex. If the code was 30, 40, 50,000 lines. Okay? The person who writes code like this up top, it's their code is awful. It's unreadable. It's unmaintainable. The person who writes code like this at the bottom, that's how we write code. That's how we maintain code. That's how we write readable, elegant code that runs right. Okay. So you go through these examples and you'll see that over and over again. So I have lots of examples here that show you all of those techniques and why we have those guidelines. Okay. And then we also explain, in theory, why we do stuff like this. Okay. So modularity, what does this mean? Don't repeat yourself. If you repeat code, it means you're probably doing something wrong. Okay. So I'm not going to go too deep into this. This is already getting, this whole talk's getting too long. I'm just going to say that we will talk about modularity a lot in all the classes, no matter what class you are, beginner to advanced. And if you have any programming classes at all, you should know about this and you should read this. Okay. So read through this and make sure you understand it. The only two things I'm going to point out about this that are really important is you're allowed one and only one return statement per function or method. Okay. That technique, that's a real technique in computer science. It's a real technique in mathematics. It's a real technique in programming. It's called the single entry, single exit method. Single entry, single exit. Okay. It's kind of a philosophy. It's kind of a school of thought. It's very mathematical, right? And it's also a teaching technique. Okay. So now, in the real world, would you have one and only one return statement per function? Probably not. Okay, I do. Like if you look at my professional code, I've written things that are, I think the biggest thing I've written by myself, like completely alone, at this point is like 120,000 lines. Okay, which isn't even that big. I'm just saying something I've written completely by myself, like nobody else helped me. I just sat down myself and wrote it. In 120,000 lines, do you know how many functions I have that are more than one return? Zero. Okay. I don't need them. I can always write something better. Okay. But are there cases where it's okay professionally? Like probably. Okay. I'm not going to say that there's no case where it's not okay. All right. But I'm also using it as a teaching technique. I want you to learn to do one and only one return statement because it will teach you to think different. It will teach you to use logic differently. So this is one of those ones where 100% it's a teaching technique and 90% it's a professional standard. Okay. And there are exceptions, but first get good at this and be a professional and then decide when those exceptions are. Okay. So in class, you have to do that or else I give you a bad grade and send your code back. But I want you to read this all very carefully. This is important information. I'm not going to go too deeply into it because there's lots of different levels of people listening to this lecture, beginners up to advanced. Advanced people, you already know most of this. The beginning people, it doesn't mean anything to you yet because we haven't gotten that far. So read this and reread it as you go through the course. Okay. Driver files. Driver file is the file that starts everything. So your main. Okay. It's your main.py or your main.cpp. It's the one that has the main function in it. And we have rules for main. Main is different. The driver file is different than other files. One big rule is one and only one function in the driver file. Don't place other functions in the main file. Driver files stand alone. One file, one function, nothing else. Okay? And you have one and only one driver. There are exceptions though. So this is another one of those like always one and only one driver, except okay, like JavaScript, some client service architectures have different things, but we won't worry about that. Okay, so you go ahead and read this and make sure you understand it. Parameters, variables, and local scope. You read this. I'm not going to go through it all. I'm just going to point out one thing about it, which is something that if you're past programming one, you already know this. If you're in programming one, this is probably maybe the first time you're hearing it. We do not use global variables without a very good reason. There's almost never a good reason. Okay, and it was easier is always a bad reason. Okay, no global variables, and I guarantee in class you will never use one because I'll never give you an assignment that needs one. Okay, in fact, I think like 30 years of professional programming, I can only think of one time where I was forced to use a global variable, and it wasn't my fault. It was a specification of the language that required it. Okay, and it still irritated me. Okay, there is no excuse for a global variable. All right, but there's more to this topic. Read all of this. All right, and that's it. I give you some examples of scope and variables at the bottom, and that's it. So this is all procedural. Okay, I'm going to very lightly touch on the next one, which is object oriented. There's two parts to this. All right, I'm not going to go through this one hardly at all because it's a lot of repetition. And if you're a beginner and you're in programming one or even like starting programming two, this won't make sense to you yet. And if you're more advanced, you know a lot of these and you're capable of reading it on your own. Okay. So basically this is all this page is doing is it's taking the procedural guidelines and it's adapting them to object oriented. So just like over here, just like we had, we started off with naming conventions, well, almost started off with it. Over here, like we start off with naming conventions, right? Because it's a little bit, there are some additional things to say about object-oriented naming conventions. Modularity, same thing. We had modularity in the previous one, but we want to add some things to the modularity discussion because object-oriented is more modular. It needs more rules. Okay, so that you go ahead and read through this, all right? Attributes. Attributes are parameters, okay, or variables, right? I should say parameters, variables. They're class variables. And basically the same rules apply, but we have a few more rules for attributes because they do other things inside of a class. All right, so we have rules for that. Methods are functions. Same rules apply for functions, but just a few more, right? And then we talk about setters and getters. You can read this yourself. And then we have a theoretical discussion about setters and getters. I find this pretty interesting. You should read it. I find this interesting because there are kind of two schools of thoughts about setters and getters. The very, very, very old school way of looking at setters and getters is you always make them. I remember, in fact, that used to be built into integrated development environments. Like I remember, I would start up an IDE. This is like over 20 years ago. You would start up an IDE and you'd build a class file, and you could like right click on the file, and then hit setters and getters, and it would just build them all for you. Okay, because it was just assumed, right? So what you would do is you would write in your attributes, and then you'd right click and say build setters and getters, and it would just build one for every attribute. Okay, that's super old school, like early days of object-oriented programming. And yes, I was there for that moment. But we evolved past that, and then what happened is the pendulum swung the other way, and it swung so far the other way where we came up with this complete opposite rule, which said never have setters and getters. Okay, and both of those are wrong. Okay, and as most things in life, like the extremists are almost always wrong. Okay, if you take anything, doesn't matter what it is, politically or otherwise, or socially or religious or whatever. Like if you look at the extremists on either end of the spectrum, they're almost always wrong. Okay, the truth is always somewhere in the middle. Okay, and same thing here. The people who always write setters and getters are wrong. The people who say never use setters and getters are wrong. The truth is somewhere between the two. Okay, and that's what this talks about. So I want you to read it on your own now that you have this set up for it. We have rules for constructors, and we stop there. Okay. So I want you to read through this. I don't want to go through it. This is not meant to teach you at all. It's meant to point you in the right direction so you can read it yourself. All right. So we're good on this, and good luck with it.